Okay, this is the video for lesson 2.2. We start with the warm-up. What is the slope of a horizontal line? So last lesson we looked at slope by picture, graphs, and also by calculating, and we learned a few special slopes as in positive, negative, zero, and undefined. So horizontal lines, I'm thinking of the H here, which reminds me of the word hoy, and the middle letter of that is O, which tells me that the slope is 0 from last lesson. To find the slope between 2 points, this is where we label the coordinates, which I can't write on here, I don't think. So it's going to be x1, y1, x2, y2, and then we use that formula y2 minus y1 over x2 minus x1. So I would do 5 minus 1, which is 4, divided by 6, take away negative 2, which is 8. Now 4 over 8 is not an option here, so you have to simplify that fraction, and then you can pick out that number. You, of course, should be doing this on paper for a question like that. And then this is just my little blank screen as a little chance to talk about questions 1 and 2 with students. And then we're going to get into the main point of the lesson, which is graphing lines that are in straight line form. So slope-intercept form is the most common form we have, and that means that we start with y equals, where the m represents the slope. And in last lesson you actually saw a picture of a mountain, and that's because of the different slopes. So it was the French word montagne. So m tells you your slope, and the intercept that it refers to on the end here is the y-intercept. So when we draw a graph, we can figure out what the slope is and the y-intercept, then we can actually plot the points to represent that. So in terms of this box, m represents the slope, and the b at the end represents the y-intercept. So it's important that we know what we're looking for here. So in other words, the number in front of the x tells us what the slope is, and the number without a variable tells us what the y-intercept is, as long as the equation starts with y equals, and that's really the important part. Now from there we can start answering questions on this. So the slope is the number that has the x with it. What we don't want to do is, which is quite a common thing that students do, is they say, oh look, the first number here tells you the slope. Well, it does if it's written this way round, but you can also write this as b plus mx as well. So the number with the x is going to be the slope, and the other number is going to be the y-intercept. So as long as it starts with y equals, which thankfully all of these do right now. So the slope is how many x's we have, which is 2. And I'm just going to go down the side here. This will be negative 2, 3, negative 1/2. The number with the x is 3. They try to switch it around on us, and 4/3. So finding the slope is actually really easy to do. You're literally just looking for the number with the x. And then the y-intercept is the number that doesn't have the x with it. So on the first one it would be 3. On the second one it would be, it says positive 3, so I'm just going to put 3. It says subtract 2, so I'm putting negative 2. Subtract 3 is negative 3. 1/2 would just be 1/2. And positive 5 would just be 5. And as you're doing this, you'll actually get a check mark. So actually, if I put the wrong answer here for a second, like if I put negative 5 here, you'll actually see as you're filling this in whether you're doing it correctly or not. So when we graph in a straight line, basically there's a couple of things we're going to follow from. We're going to plot basically a couple of points, at least 2 points, and then we can join them up with a straight line. So one of the points that we use is that intercept. So we begin at the number without the x, that's the y-intercept, as in on the y-axis. And then we use the slope to count squares, that rise over run like we did last lesson, to find where a second point is. I would normally continue then and do another point if I can fit it on, and then I would connect the dots together. And we'll see how that works on a question in a second. So it's important that we know the difference between which number is the slope and which is the intercept, or else we're going to plot our graphs incorrectly later. So these are examples that students would follow along with, and then after we've done a few examples, you're going to try a few questions, and then we'll try some more examples, and so on. So for this here, this 2/3 x plus 1, the number without the x is where we start from on the y-axis. So at positive 1, we plot that first point. Now the slope here, 2/3, it says don't forget this rise over run. So the top number is rise, and the bottom number is the run. So that means that I go up 2 squares, and then I go across 3 squares, and I put the dot. Now on the last slide it said you can just join this up with a ruler, and you absolutely could do that. I'm going to ask you just to keep going, go up 2 and across 3, go up 2 more and across 3, and keep doing it until you basically run out of space. And it just makes that line just that little bit easier to see, and if you are using a ruler it'll make it a little easier. If you're taking something like the SOL, normally what will happen is after you plot the 2 points, it will automatically join it up with a line. You can click the line icon if you wish, and it will actually draw the line. I don't really want to stop here because this line continues forever, so I'm just going to bring it back a little bit just to show that that pattern continues. If for some reason you make a mistake, you can always click on the eraser and you can get rid of some of those points as well. 1/2 x minus 3. So I'm looking for, first of all, where do I begin from? What is that y-intercept? So the number without the x, so -3. So go down to -3 on the y-axis. And this time the slope is 1/2, so that's a rise of 1 and a run of 2. A rise of 1 and a run of 2. And just like last time, I'm going to do this as many times as I can until basically I run out of space. And it'll just make your graph that little bit clearer exactly where it goes, and it'll help you practice the idea of slope as well. And then I could use the line tool to draw these up. I didn't quite get them there. Whoops, that last dot is definitely not supposed to be there. Let me see if I can erase that one without touching the other ones. There we go. And then I could use that line tool if I need to, but the dots are perfectly good at this point. Now, you can also have a negative slopes as well, so I thought that was important to look at. But also notice this time, there is no number without the x. So this is one of our special cases we've got to be a little bit careful for. If there's nothing on the end, what that means is it means that it starts from 0 on the graph. So we're not going to put +0. We would just leave this part empty. The slope of -4/3, so the negative applies to the top number here and not the bottom number. So -4/3 means -4 divided by 3. So I'm not going to go up 4 squares as a rise because it says negative. So that means I'm going to go down 4 squares and then I'm going to run 3 squares. Remember, the run is always to the right. Go down 4 squares, across 3 squares, and then I could connect these up with that line tool if I want to. And the last example, 6 minus 3/5 x. So the starting number is the one without the x, so the 6. So that's where I start from on the y-axis. Oops, I just clicked in the wrong place by accident there. So I'm going to start at 6, and -3/5 means I go down 3 because it's negative, and then I run 5 squares. Go down 3 squares, and across 5 squares. And in one of our later units, we're actually going to look at things like what are the x and the y intercepts. So clearly you could see the x-intercept here. And actually by plotting, you can see that the y-intercept is 10. And we'll look at that in a future lesson. So at this point, you've got 4 for you to try yourself. You'll be allowed to look back at those previous examples, but there are a few notes here to remind you. So where do we begin? The number without the x. And how do we move? This one here tells you the rise over the run. And you can try those 4 questions yourself. Once again, if there's nothing on the end here, remember what that means in terms of where you start from. So, after students have had a chance to try on that, we'll move on to our next questions. So next one doesn't look that different. We've got a number in front of the x and we've got another number at the end. So -8 at the end is the number without the x. So that means I start at -8. Now, the difference is the fraction questions are actually easier than the non-fraction questions because we have naturally a fraction to do rise over run. So there's a little reminder here what to do if that happens. If you don't see a fraction, you make it into a fraction by putting it divided by 1. And the reason that's okay to do is 2 divided by 1 is 2, so that doesn't cause a problem for this. So as I'm doing 2, what I'm actually doing is 2 over 1. So I'm going to go up 2, across 1, up 2, across 1. And I'm just going to do it a few more times. Up 2, across 1. Up 2, across 1. And hopefully you'll do it just a little bit more accurately than I'm doing it right now. Until I'm off the graph. And it should make a perfectly straight line. I actually missed that dot here, and actually I missed that one there. Not quite so easy as when you're doing it with pen and paper, so I'll allow a little bit of accuracy when you're doing these questions. This time I got -3x plus 6, so the number without the x is where I start from. And then the number with the x is my slope, and same thing again. This is just a single number, so we're going to rewrite this as -3 over 1, which means I'm going to go down 3 and then across 1. Down 3 and across 1. And that question I was talking about earlier, they might ask you what is the x-intercept of this question, and you can see that it would be 2 from here. Okay, down 3 across 1, down 3 across 1, down 3 across 1. And I didn't quite get those 2 dots in the correct place, but hopefully you can do that a little more accurately than I just did. And our special ones from last time. This time we've just got y equals a number. Now I could actually plot this one how I did the previous one. So I could start with 5 on the y-axis. And notice there is no x's here at all, which means a slope of 0. And from last lesson we know a slope of 0 is a horizontal line. What I'd really like to do, though, is questions where there's only one variable, and all the other ones had 2 variables. I'd like you to think about the words hoy and vux. So depending on which letter they give you, so if they give you y, then pick the word that's got a y at the end of it, so hoy. So I know I'm going to draw a horizontal line, and I'm going to plot 5 on the y-axis, and then I'm just going to draw that line straight in. So that's actually kind of a quick question to do when you see those ones. And for number 8, same thing. I only have one letter here. This one's the first one that starts with X rather than Y. I only have one variable, so I want to think about my words hoy and vux. So vux is the word that ends in an X. So I'm going to go to -2 on the X-axis. So notice this is a slight change how we plot this as well. So I'm going to go to -2 on the X-axis. And then this time I'm going to draw a vertical line going through that point. So it should look something like that. So those hoy and vux are really useful for helping you to graph lines, but also to remind you what the slope is. So just remember for this one, u is undefined. And for this one here on hoy, this is not really an O, it's actually a 0, but the slope of a horizontal line is 0. So we can use those to help us. And then same thing as before, 4 for people to try. Little mental notes here just to remind you in case you've forgotten how to do each of these questions. And then gradually the help gets removed slightly as you get a little further in. Keep an eye out for those ones with just one variable. That's those special horizontal and vertical lines. And just make sure you pick the right one for that. Right, our final graphs for this question doesn't look particularly any different. It's just so how we start this is how we start the previous one. It does start with y equals, which is an important first step to check. So the number without the x is where I'm going to start from, which is 2. And this time, not only is there no fraction, there's actually no number with this x as well. So we've got to remember x means 1x, and then we can also make it into a fraction by dividing by 1. So x would be 1 over 1, and that means I go up 1 and across 1, up 1 and across 1. And you can just keep doing this. Now the characteristics of the graph that start with an x, they're basically a perfect diagonal. So we can use that to help us as well when we're trying to identify which graph is the correct one. That it should be just that perfect diagonal going through squares like that. This time -x. Now notice it starts with y equals, so we know this is slope-intercept. There is 2 variables, so it's not horizontal or vertical. Now there's no number at the end here, so remember when that happens it's because it's 0. Now this one, same thing, not a fraction, and there's no number here, so this should be -1x. And then we can put it over 1 to make it into a fraction. So -1 over 1 means I go down 1, across 1, down 1, across 1, down 1, across 1. And then I can keep doing this until I get to the edge of the graph. And I'm kind of rushing this a little bit, but I think you get the idea. And then I can join it up with that tool if I wanted to and make it go all the way. So just a couple of things, just to make a look at the shape as well. With this being a positive value here, you can see that the graph's going up. And then on this one here, as you can see it was a -x here, you can see that this is negative slope. So that's also a little tool that will help us as we draw in our graphs, just to check is it positive or is it negative. Now, I went into a little more detail here. Eventually we're going to start looking at literal equations, and we're going to start looking at graphs that don't start with y equals. So I thought we'd introduce that today, but not get too complicated too quickly. This actually links in with our solving of equations. So if I know what 2y is, if I want to find out what y is, I just do the opposite of timesing by 2, which is to divide by 2. Now if I do that here, I also have to do it on this other side as well. So 4x divided by 2 would give me 2x, and -6 divided by 2 would be -3. So the graph I got to plot is 2x minus 3. So I'm going to start from -3, and then that 2x means I'm going to write as 2 over 1, so I go up 2 and across 1, up 2 and across 1, up 2 and across 1, and so on. So if a graph doesn't start with y, the important thing I put this question in for is that people don't start at -6 and then draw a slope of 4. It is important that you check, does it start with y equals if you want to do slope-intercept form, and if it doesn't start with y equals, then make it start with y equals. Our last example, this doesn't start with y equals either. It starts with 2x plus y equals. Now, if I'm trying to make this say y equals, then I've got to move this 2x across to the other side. So from our last unit, when we want to move something from one side to the other side, we have to do the opposite. So this 2x, this positive 2x, therefore the opposite would be to be negative 2x. So this equation really, if I want it to start with y equals, should be y equals 5 minus 2x. So the number without the x is 5, so I start there on the y-axis. And then that negative 2x, I can put it as negative 2 over 1, so I can go down 2 and across 1, down 2 and across 1. And you can see this negative slope forming here. Whereas if you only look at the number of x here, you might say, oh, 2x, that means 2 over 1, so I'm going to go up 2 and across 1. So it's really important that you make equations start with y equals if you're going to use that slope-intercept form method. And then the same thing as before, there's a few for us to try here as well. So main thing is, the numbers with, if it just says x, you might want to put that little 1 there at the start. And just remember what to do if there's nothing at the end, what that means for the intercept. Same thing, if there's no number here, you can put a 1 there if necessary to help you. This time I made it 4y rather than y, but you've got to make it say y equals as it will remind you in the question here. So think how you would do that. And same thing for this one. It doesn't say y equals, so think about how you'd move negative 3x to the other side, and then you can start graphing that one as well. And then just at the end, I started to put in some of the graphs that we should be getting used to now. So first of all, the one that's slope-intercept form. I don't really like the dash here because it looks like a negative. It's supposed to just be y equals mx plus b. Horizontal lines are y equals a number, that's from Hoy, and vertical lines are x equals a number, which is from Books. And we're going to start, those last few questions we looked at is going to help us to transition into something called standard form next lesson. We actually have x and y on the same side of the equation, and we have to try and make them basically into slope-intercept form. That should do it for this video though, and I'll see you next time.